Here we have a buffer solution, and we're going to add some acid to it, and we need to figure out the pH of the solution after the acid has been added. So the acid that we're adding is HCl. It's a strong acid. We need to figure out the reaction of HCl with the buffer, and it's going to react with the conjugate base of the buffer since acids react with bases. So let's write out the chemical reaction for HCl to react with ascorbate to make more ascorbic acid. Notice when we write the equation out that we use a arrow that only points to the right because this reaction goes to completion. Now we need to use the numerical values in our question to figure out how much of each of the materials we will have after this chemical reaction. So this is a stoichiometry problem like what you did in first semester general chemistry. When this reaction happens, the moles of HCl will be all the way used up to generate more moles of ascorbic acid and use up some of the moles of ascorbate. So we subtract 0.002 moles from the reactants, each of the reactants, and we add 0.002 moles to the products. We're ignoring chloride because it's a spectator ion. In other words, it's neutral and it doesn't have any effect on the pH. So at the end of this chemical reaction, I have my new moles of ascorbate and moles of ascorbic acid. Now I can use those to figure out the pH of my solution. Again, we'll write out the chemical equation, but this time the chemical equation is the equilibrium reaction of ascorbic acid reacting with water. And I'm going to list at the top of my equilibrium reaction the number of moles of ascorbic acid and ascorbate that we're going to have from the calculation on the previous slide. Now we'll go ahead and use the Henderson-Hasselbalch equation. We can leave our ascorbic acid and ascorbate in moles instead of converting them into molarity because the volume of ascorbic acid and ascorbate are the same, so their volumes will cancel. So I need to find the pKa for ascorbic acid from its Ka, and then I can do the rest of the math, plugging in the numbers, and that gives me the answer, which is 4.19 for the pH of the ascorbic acid buffer.